whole idea of the chart. We have to kind of think about what each thing is giving us, and it's really important that you understand not only what this looks like, but also how it works. So if f is increasing, f prime is positive, and we really don't get anything about the second derivative. If f is decreasing, f prime is negative, and again, we don't get anything about the second derivative. Notice that if we go from the first line to the second line, f prime is going to equal 0 or be undefined, and f has a relative maximum. If we go from the second line to the first line, again, f prime is going to equal 0 or be undefined, and f has a relative minimum. Okay? So really important to kind of gauge. That's the only information you have. If f prime is going from positive to negative, f is going from increasing to decreasing. F prime is going from negative to positive, f is going from decreasing to increasing. And we really don't have any information about the second derivative. Now, when we get to the next part here, excuse me, when we get to the next part here, if f is concave up, so I didn't write the words concave up in there, but concave up, f prime is increasing and f double prime is positive. When f is concave down, f prime is decreasing and f double prime is negative. Now, we have a little bit more going on with this one. So when we go from either direction, whether we go from this line to this line, it doesn't matter. Both of them, f double prime equals 0 or undefined. F has a point of inflection, and f prime has a relative maximum when we're going from the third line to the fourth line. On the other side, f double prime equals 0 or is undefined. F has a point of inflection, and f prime has a relative minimum. Now, when you think about like what a relative minimum, what a relative maximum looks like, remember, a relative minimum looks like that. That's what a relative minimum looks like. A relative maximum looks like that. Points of inflection are where you get a change in concavity. So a point of inflection is where a graph goes from concave up to concave down. It might go concave down to concave up, and it can be in any direction. But these are points of inflection. Notice you could also have a point of inflection where you go concave up like this, reach that right there, and maybe like this. Now that is not a point of inflection because that's going from concave up to concave up. So you got to really make sure that you understand what a point of inflection is. A point of inflection is where you change concavity. Okay, a point of inflection is where you change concavity. So really important things to know. So that chart is super important to know. And then interpreting it. And then you get this right here. And then these are what points of inflection look like. So if you look at this chart, and if we kind of keep that chart in our mind, and I'm going to shrink this down, so I'm going to do a couple problems or talk through a couple problems with you on this. So take this chart right here, and I'll put it like that. Given the function f prime, so this is the derivative. So now we're given this middle column right here. What conclusion can be drawn from the sign chart of the given function, and this kind of would help us with a sign chart, of the graph of f when x is less than -6. So the idea behind here is we're making a conclusion on f from f prime. So let me show you what I mean on that. So if f prime is equal to this -3x squared, x plus 4 squared, x minus 6. When x is equal to -6, or this is x plus 6, when x is equal to -6, and we think about where that is, so let's say right here, we really want to kind of say, well, what happens when we test a value smaller than -6? Like, let's test x equals -7. If this value right here is -6, and we want to test what's happening at -7, we want to test f prime. Notice that when we put in -7 into f prime, we get -3 times a positive value, because that would be -7 squared, times another positive value, because again, we're squaring it, times a negative value, because -7 plus 6 is still negative. Notice that this whole conclusion is negative. So if f prime is negative, what we can know is we know f must be decreasing. So if we're trying to draw a conclusion about f over here, we know f is decreasing on that interval, and we get that value. So give some of these a shot, but you got to kind of make sure that you understand what's happening with this chart. And if you know that chart, these problems shouldn't be terribly difficult. Let me know if you have any questions.